So this example, what we are going to do is this one. Okay? So let me explain what this one does. Basically, this is like just a soda can, and this is like a rubber band. Okay, so because if you pour more water, if you put some more water, it has heavier. That's why this one is kind of more stretched out. So that's actually one measured here. This is the length. So length is from a two like ink spot. So when the volume is a 0 milliliter of the water is pretty light, then they measure this length. But as they put more kind of water into the soda, it kind of going down, and then this length is kind of stretched out this much. Okay. So using this data set, we are going to kind of analyze this one here. So our first task is this one. Okay, our first task is this one. Using Matlab, enter the length value as a one row vector and the corresponding weight value as another row vector. So now we don't need to enter it because we want to load it. Okay, we want to load it. But in here, please make sure that this one is a weight, and I want to convert the water volume to the weight, and so on. So if you go to the course website, you can download the TXT file that has this two-column data set. Okay? So this one is a Matlab example TXT. So go to the course website, and here, so Matlab example TXT here. So Matlab example TXT. So I typed down already the length and volume. If you click this one will show you this value on your web browser. In that case, click the right button and save as. Okay, save as your TXT file. So I want to save as this Matlab example TXT file. Save it. I saved it. Once you saved it, go to the Matlab. Okay, so from now on, we are going to work this data. So step one. Okay, load. So I want to load the file. Okay, so I already explained what kind of. So we have many different ways to load a file. So what do you want to use it? Read matrix is most simple and powerful way to do that. Okay, read matrix. So I want to use the read matrix. Okay, and then on my working folder, let me see. I have this file. Okay, so read matrix and parentheses, and I want to Matlab. So this Matlab automatically fill, and after that I want to dump all the value into my array variable. So let's say I call it like for example, what do you call it? Maybe just data. Is it okay? Just data, or maybe whatever you want to call it. Okay? So after that, let's try to run one line. So if you try to run, now you have a data here, data. So if you want to see the data, you try to double click, or you can just type here data like that. So this is my first column is length, and second column is the volume of the water. Okay. So after you call the data set, after I want to create a variable length. The length should be data, my first column of my data, so it must be colon and 1. That's my length, right? The volume the volume is data and second column, right? This is the first column. So we just split our data into the length and volume variable. Okay, after that, I did that. Okay, then so now we know that this kind of volume of the water. So how can we convert the volume to weight as a force? So because I want to display my volume as, I want to actually display my volume as a weight, because the reason that I want to pour more water is we want to make more weight. So I want to display it out as a weight. So how can we make as a force? So here, okay, the force due to the weight of the water is this one. So the force, as you know, force is equal to ma. According to the second Newton law, force is equal to ma. So a is acceleration, which is our gravitational accelerations. So this is a mass. This must be the mass, right? So mass is equal to what? Mass is equal to volume times density. Density times volume is a mass, right? So that's why your force is equal to the density of the water, which is 1,000 kg per meter cubic. Volume of the water. Right now, these are, the density was represented by kilogram per meter cubic. So that's why in order to use that, I need to change my volume units to meter cubic, okay? Meter cubic. But this one, the volume is in milliliter. This is a milliliter, right? So we have to convert something here. So milliliter, one milliliter, milliliter. So if you think about the water volume, let's say this is a 1 centimeter and 1 centimeter and 1 centimeter. 1 centimeter, 1 centimeter, 1 centimeter volume of pure water becomes 1 milliliter. So we want to convert this one to meter cubic. So that's why using this milliliter volume, I want to convert into the meter cubic meter cubic. So that means 1 milliliter is what? How many? What's the meter? So you know that 1 millimeter is 1 centimeter cubic. 1 milliliter is 1 centimeter cubic. So my question is, what is this meter cubic? So what is the 1 centimeter is what meter?
100?
Hmm?
100? 100?
No.
Oh,
100.
0.01.
Yeah, 100 centimeters is 1 meter, right? Yeah, reverse it. So this one is
0.01.
right. So thank you for that one. So that's why this is cubic. So 1 centimeter cubic, this is 3 times. That's why this one should be 10 to the negative 6 meter cubic, right? So that's why in here, 10 to the negative 6 meter cubic. So that's why if you want to convert the volume to the meter cubic, you just multiply 10 to the negative 6. That becomes your meter cubic. After that, if you multiply the density, it becomes mass. Okay. So now, let's convert this one. Let's convert this one to the meter cubic volume. So I want to let me just elaborate my variable name. It doesn't need to be very long, but for the purpose of our exercise, let's try to just expand it. Okay? I want to just make a volume is a meter cubic. So as I said, you can just multiply the volume multiply 10 to the negative 6. Okay, 10 to the negative 6. So 10 to the negative 6, you can probably put like a 10 to the negative 6. You can just write down something like that. But in the Matlab, the more easy way is you can just try to use something like this portion. So for example, if you type 1e minus 6, this becomes points. So let me see. 1e minus 6 means you can just multiply 10 to the negative 6. That's the same. Okay. So I just multiply that. So this becomes like meter cubic volume. Okay. So from now on, what is the water density? So density, water density was given, which is a 1,000. So this is the unit is kilogram per meter cubic. Okay? So your force as a weight, your force must be water density times and then volume. Okay, volume. V-O-U-L. Let me just spelling volume as a meter cubic. Okay. Let me just put the 3 instead of cubic. Meter cubic. So this is a mass. This is a mass, right? And multiply by gravitational acceleration 9.81. Let me just be more accurate. 9.8067. So now we try to get the force for each different the soda can. Okay, so let's try to run. Let me run. Okay, let me run this one. Boom. So I ran without any error. That's good. And second task. Okay, so until now, our second task is that let's make a plot. Apply the force on the y-axis versus the length on the x-axis. I want to make a plot. So force on y-axis and length on x-axis, okay? Like that. So how can you make a plot? We learned how to make a plot, right? So figure and plot. And my x-axis first. My x-axis should be length. So length. And force. And I want to make this one a little bit thick, so line width 2, and after that I put the X label length as a millimeter. I think millimeter. Let me double check. Yes, millimeter. Okay. This is millimeter. And Y label as a force. This is Newton. Okay. And if I want to put the grids, I want to put the grids. Figure. Okay, so let's run. So I have this figure. In this figure though, I want to add the marker for my actual data points. Okay, I want to add a marker. So in a case, when you make a figure, I want to click this one. I want to add like a circle, and circle, and then the circle is connected by like a, for example, dotted line. So I don't care about the color. So if you want to take care of the color, so color is, for example, red. This is my red color, and marker, and what is connecting line type. Okay, so you can just specify all of them together. Or if you don't care about the color, I just care about what is marker point, what is the connecting line type. So if you run this one, let me just delete the figure and then let me run one more time. Then you have this figure, right? So as you see that as you increase the force, the rubber band kind of stretched. Rubber band stretched. Okay, so this is not everything. So as a third task here, convert the data to new row vector, one representing stress, the other representing strain. So what is a stress? Stress is a force divided by the initial cross-sectional area of the rubber band. That's the stress. So for example here, if you measure the stress, let's say you apply the force and then your specimen is getting kind of thinner. So in a case, the stress is something like this one here. So stress here is whatever force divided by cross-sectional area. So stress is like a force per unit area. That's the stress. And what is the strain? Strain is, so the L naught is the initial original space. So the strain is whatever the like stress length divided by the original length. That's the strain. Right? So because L naught is original length, that the L minus L naught is stretched length. So that stretched length divided by original length is a strain. So now our rubber band is kind of stretched. So I want to divide the stretched portion by the original length. That's the strain. Also, rubber band has a certain cross-sectional area. So I want to divide the force by that area. So when you look at this one, the rubber band has 5 millimeter and 0.5 millimeter. So it's a square rubber band. So my area is 2.5 millimeter square. Okay? But I want to change this one to meter square as well. Okay? So let's try to do that. Okay? In here, I want to add first step 3. Let's see. Step 3, stress versus strain. So stress is equal to force divided by area, right? But we didn't compute area yet, so that's why in here I want to compute area. So our area is equal to 5 times 0.5. But this unit is a millimeter square. Okay, that's the unit. So I want to convert my area to meter cubic, meter square. Meter square. So as you know that 1 millimeter is 10 to the negative 3 meter, right? So that's why 1 millimeter cubic is equal to this one again, 10 to the negative 6 meter square, right? So that's why if you want to convert your area to meter square, then you have to multiply same 1e minus 6, that's the 10 to the negative 6, and I think this becomes your meter square. Okay? So after I convert the area to the meter square, then I divided my forces so that I can get stress. And then strain. Strain is stress length divided by my original length. So what is my original length? So my original length is when I look at my length, let's look at the length. So when I look at the length, my first one is 75. So the 75 millimeter is my original length, right? So L0, okay, LO. Maybe you can. I just write down here. Okay? Original length is equal to 75. Okay, or maybe you can say length of 1. That's my original length. So my strain is my stretched length. My stretched length divided by original length, right? So strain must be be careful. Your strain looks like this one. So the strain is length, okay, minus your original length, right? Original divided by original length, right? I just follow the strain formula, right? Your strain is length minus whatever the current length minus your original length divided by original length. That's a strain. And so that's why now we figured out stress and strain. Okay? Then you make a plot. You make a plot. So let's make a plot. In here, I want to make my x-axis as a strain, and my force, instead of force, I want to put the stress, and my x label is a strain. Strain doesn't have any unit, okay? Strain doesn't have any unit, and stress is force divided by unit, force divided by the area. So it has like Pascal, that's the unit. Okay? So I think everything is okay. Let me run. typo, original. Yeah, typo. Another typo. So now I show you a second plot. So strain is on the right x-axis. So if I show you my first plot, actually the pattern is exactly the same, right? Exactly the same, but the units, the x and y, we just convert it to strain, and for the force we convert it to the stress. Okay? If you want, you can make your two plot on the same figure if you want. So for example, we call the two figure, so instead of making two figure, on line 13, for example, I make a subplot and 2 by 1 1 and plot, and the next one I just delete the figure and then I just call the subplot 2 1 2 like that. So in a case, if you run the first plot, it shows your plot on the top, and then the second one, including the subplot 2 1 2, then you can include the second one on the bottom one. So in a case, you can just make a two plot on the same figure. So after that, the last one, save your stress and strain data. Okay. So I want to save my stress and strain data. I want to save it. So easy way is this one. So for example, I just put the output. My output is stress and colon and stress and colon and strain. I want to just combine. I want to combine it. And what is it? Save. Stress, strain data, for example, txt, for example, stress, strain data txt, and I want to save output as ASCII. So I want to, because in order to save it, I want to combine stress and strain like that, and then I save it as this file name, and I save this my variable output and ASCII. Okay. So when you run it, I saved it here. So if you open it, it has. Let me open it. This is a download. When I look at this one, it seems like this one just saved as one like a big line, because my strain itself, when I look at my strain data set, my strain is already 11 by 1, stress is 11 by 1. So I want to actually transpose it here, transpose it. So I transpose stress here and strain there. So let me just resave this one. And I saved it, and after we get, now I can make this one is 2 line. This is 2 line, like that. So this is kind of one exercise, one example to use the Matlab with actual experimental data. So this late afternoon, please come. Okay, please come this late afternoon. I'm going to show you one more example from my own experiments. We are going to analyze the data, and please come this afternoon. I have another example, so it will take about a little bit more than 1 hour, so please come. I will be finishing everything by 5 today. Any questions about this example? So Matlab is pretty powerful. This is just a simple example, but with Matlab you can do any types of analysis of your data, including the plotting. Okay, so have a good break. So don't tell me you have another class right after this one. Nobody has a class?
I have work.
You have a work?
I have to go to work afterwards.
Oh, then you have to come back again.
Yeah.
Where do you work?
I work for IT. I work in the James building.
I see.